Hi everyone and welcome to my channel. I'm Eugene and this channel is dedicated to teaching of programming and software development. In the previous lesson, we learned about development environments and we prepared our development environment. This is the third Programming Fundamentals lesson in which we are going to learn about data types, variables, and numerical systems. Let's begin with understanding what variables are and why we need them. A very basic requirement of a program is storing data during the execution of the program to perform its task. For example, consider you need to write a program that will calculate the sum of two numbers. You will of course need to get these two numbers from the user, but you will need to store them to be able to perform the calculation. Once you have the numbers, you will need to store the result somewhere as well, so that you can show it to the user. This is exactly what variables are used for. A variable is a labeled storage place where a program can store data during its execution. The name of the variable is constant, which means it can't be changed. We access the variable using this name. In contrast, the value of the variable can be changed whenever required. Except for the name and the value, another very important characteristic of a variable is its data type. The data type is the kind of data that can be stored in the variable. There are different data types like integer numbers, floating point numbers, characters, and more. But what's important is that the data type, just like the variable name, cannot be changed. If a variable was declared to store numbers, it can store only numbers. Now, consider we would like to create a variable and store a number like 250 in it. As you remember, computers can store data only in the form of 0 or 1, or in other words, in bits. A bit is the smallest unit of data a computer can store. But if the computer can store only bits of 0 or 1, how can we use these bits to store different data, for example numbers such as 15 or 250? To answer this question, let's see what numerical systems are. A numerical system is a way of representing numbers using a set of symbols. There are different numerical systems like binary, octal, decimal, hexadecimal, while every numerical system has a different number of digits that can be used to build numbers. For example, people are usually using the decimal numerical system in day-to-day life. In the decimal system, we have 10 digits, while each digit can be between 0 and 9. So how do we create numbers bigger than 9? We combine several digits, while the position of the digit in the sequence of digits determines its value. For example, let's take the number 235 and see how it's built. So 235 is 2 multiplied by 100 plus 3 multiplied by 10 plus 5 multiplied by 1. You can see that the most right position means that the number in that position should be multiplied by 1. In other words, how many times we count 1. For 3, it's in the next position, and it means how many times we count 10. And for 2, it's how many times we count 100. Pay attention that each position in this case is a power of 10, while the most right position is 10 to the power of 0. The next one is 10 to the power of 1, and so on. So in case of 235, you can see that the number is built of 3 digits, 2, 3, and 5, but the position of each digit has its own value. Now, in case of computers, they use the binary system in which the only digits used are 0 and 1. Now, except there are much fewer digits, the principle of building numbers is absolutely the same, like with the decimal numeric system. If we look at the example of 1001, it will mean 1 multiplied by 2 to the power of 3 plus 0 multiplied by 2 to the power of 2 plus 0 multiplied by 2 to the power of 1 plus 1 multiplied by 2 to the power of 0, which is 8 plus 0 plus 0 plus 1, which means 9 in decimal. As you can see, just like with the decimal system, where every position is a power of 10, in the binary system, each position is a power of 2, because we have only 2 symbols. This way, we can represent any number as a combination of zeros and ones. Now, if we can represent any number as a combination of zeros and ones, and the memory of the computer consists of bits that can hold zeros and ones, we can allocate a number of bits in the memory and store any number inside by converting the number we want to store to a binary number. The sequence of bits is a variable. Now, how big a number stored in a variable can be? Consider we have 8 bits of memory for a number. What is the smallest and the biggest number we can store in it? If all digits are zeros, the smallest number will be 0. The highest number will be if all the digits are ones. So, if we have 8 bits, the highest number will be 255. The more bits we have, the bigger the number we can store in it. So if we have, for example, 32 bits, we will be able to store a much larger number of 4 billion and something. The size is determined by the number of bits allocated for the variable. What we have just seen is a type of variable that can store unsigned integer numbers. What if we would like to store negative numbers in addition to positive? The most common way to store negative numbers is to use a method named 2's complement. To store a negative number, we write it as a positive, then we invert all bits and add 1. For example, the number -5 will look like this. We will write it as +5, invert the bits, and then add 1. Now, except for numbers, there are other data types that can be stored in memory. One of them is a character. Now that we know how a number is represented in memory, it will be easier to understand how characters can be stored. To store a character in memory, we need to convert the character to a number which we can then store in memory. Now, there are different methods to convert a character to a number. These methods are called encoding systems. An encoding system is a set of rules that map character to numbers. One of the encoding systems is called ASCII, American Standard Code for Information Interchange. In ASCII, a character is converted to a number of 7 bits. For example, a capital A is converted to the number 65. In C#, ASCII is not used because it is very limited in the amount of characters we can represent. Instead, in C#, the UTF-16 encoding is used as it can store much more different characters. Now that we learned the basics of how variables can be stored in memory, let's see how to work with variables in C#. C# supports many built-in data types. Now we'll see the common ones. What's important is that once the variable is declared with a specific data type, it cannot be changed. Let's begin with numeric types. Int is a signed integer number of size 32 bits, and its range is from minus 2 billion and something to plus 2 billion and something. It can be, for example, 5, minus 8, 200, 1000, any integer number in this range. The next one is uint, which means it's an unsigned integer number, which means that the numbers stored in such a variable can't be negative. So the range begins from 0 and ends somewhere at 4 billion and something. Pay attention that it's twice as big as int because we don't need to store negative numbers. And the size of it is the same as int, 32 bits. For floating point numbers, we have several types. Two of them are float and double. They are basically the same, except double has a bigger range and higher precision. The float data type has 32 bits, while double has 64 bits. And we have several other data types, like bool. Bool stores Boolean values, which means it can store only two types of values, only true or false. Char holds a single character in the UTF-16 encoding and has a size of 16 bits. String is a special type that holds a sequence of characters, or in other words, text. For example, it can store the word programming. So now that we've seen what data types we have, even though we have more data types that we'll see later, let's go to VS Code and see how we can work with these types. Now we are in VS Code, and let's see how we can work with variables in C#. I created a console app in which we are going to do our experiments. If you don't know how to create a console app, you can watch my previous video, which is lesson 2, in which I explained how to do it. Now let's see how we declare a variable in C#. First, we need to type the data type of the variable. Let's begin with defining an integer number. So I'm typing int. This will be the type of the variable, and the name of the variable comes next. Let's call it, for example, grade. So we defined a variable. Now let's assign that variable a value. One of the ways to do it is this. In the new line, I'm writing grade equals 100. Now, what you see here is the assignment operator, which takes the right side and copies it to the left side. This means that it will assign 100 to grade. Let's print the value of grade and make sure that it works. All right, as you can see, we have 100 printed here, which means that grade actually has the value of 100. Now let's see another way to define a variable. Actually, not only define, but the idea is that we can define and assign the value to the variable in the same line. For this, we are declaring the variable as before. I'm typing int grade 2. And this time, instead of putting a semicolon to end the command, I'm typing equals 100. Basically, this is absolutely the same. We just did it in a single line. Now let's print grade 2. And you can see that again we got 100. Now, except for that, we can define multiple variables in a single line. Like this. We can type int. This means that the variable types will be int. And then we can, for example, define a variable of a, b, and sum. So what we just did, we defined three variables, a, b, and sum, all of them of type int. Now, in the same line, we can give them values, and not necessarily to all of them. For example, we can give a value to a and a value to b. Then sum can be given a value, for example, in the line after. Like this. Again, as I said before, this is the assignment operator, which takes the right side and copies the value of it to the left side. So in this case, first the calculation will happen, and then the result will go to sum. Now let's print sum. As you can see, the result is 5 and it's printed. So everything works as expected. As I said before, every type has its size, and the size of int is 32 bits. And its range is up to 4 billion and something. And if you need to store numbers bigger than that, you can use another type that is basically the same as int, but has a bigger range. This type is long. So long works the same as int, but can store much bigger numbers. Of course, it can store small numbers just like int. Now, there is a special command in C# that allows us to know the size of a variable, or more precisely, the size of a data type, which means how much space the variable will take in memory. For this, let's do the following. I'm going to print the size of int. So the command is size of, that returns the size of an integer number. And let's do the same with long. And if we run this, we are going to see that for int the result was 4, while for long the result is 8. The unit here is bytes, and since 1 byte equals 8 bits, so int is 32 bits and long is 64. Now, let's see how we work with floating point numbers. So let's define a double. So to do it, we do it just the same as with int. So we first type the data type, double, for example, price. And now we can we can print it. Let's print the size. Sorry, the price. As you can see, it's printed just as we defined it. Now, as I said, we have double and float data types, which are basically the same except for the difference in range. Now, if we want to declare a variable of type float, we can do it like this. Again, we can store, for example, 9.2. Now, as you can see, we get an error here. And the reason we see an error is that floating point numbers in C# are by default considered as double. And if we want the compiler to consider this number as float, we need to add an F here. This tells the compiler that this number is not a double but a float, and then it can assign it to a float variable. Now, let's try to do some calculations with floating point numbers. For example, let's define another double named tax 1.05, and then let's declare another double, which we will its value will be the result of a calculation. For example, final price multiplied by tax. So we did two things here. First, we declared a variable of type double named final price, and we immediately assigned a value to it. Now, not only that we assigned a value, we assigned the result of a calculation. Let's print final price. Okay. As you can see, it's printed here. Now, except for float and double, there is another special type named decimal. Decimal is another floating point type that works a little different. For example, decimal number. Now, first, as we said, since floating point numbers are considered double, we need to add an M here to let the compiler know that please see this number as a decimal and not double. And the problem that decimal solves is the following. Double and float are binary-based variables, while decimal is decimal-based. And the problem that happens with binary-based variables is that for some numbers, they might be not precise. And these numbers are usually numbers with a fractional component. In this case, sometimes we'll get some rounding errors when using double. So in order to prevent these rounding errors, we need to use decimal. That is decimal based, so it prevents from these errors. The only problem with decimal is that it's a lot slower to work with when compared to double. So we need to work with decimal only when we actually need it, and not with all floating point numbers. Decimal is usually used in everything related to finances, where decimal precision is very important. Now let's continue to other data types. Let's define a char variable. So we define it just like all others, using the data type keyword, which is char in this case. And then let's give it, for example, the name first. And the value, since it's a character and not a number, is typed within single quotes, like this. Now let's print this. Well, as you can see, we have A printed here. Now, in addition to char, we have a special data type that we are going to learn more deeply in the future, and it's called string. Well, string can contain a whole text, which means multiple characters. And since it's another data type, we are going to type the value within double quotes. Now, if we print this, the whole string will be printed. All right. And probably the last one for today is the Boolean data type, which stores Boolean values, and it's declared as bool. And for example, let's name it past. The value can be either true or false. So it can be either true like this or false like this. Let's print it. As you can see, false is printed. Okay, so these were the basic types. Now let's take a look at the following example. Now, what you see here is that we are assigning an integer number to a long number. And what's special about this is that we are assigning between different data types. Now, since long has a bigger range than int, we can do it without problems, because any integer number can be assigned to long, because long has enough space for any integer number. Now, if we did, for example, the opposite, like this, now, as you can see, in this direction, this can't be easily done. And the reason is that long has a bigger range. And if we simply assign a long number, a long value to an integer, there might be some data loss. So we need to tell the compiler that we understand what we are doing, and we need to tell him to consider this long as an int, which means to convert the long to an integer number. and this time it will work. Now, when we assign between different data types, this is called conversion. Now, in this case, we have an implicit conversion because int can be easily copied to long, while in this case, this is an explicit conversion. We need to add casting. We need to cast the long number to the integer number. Now, I would like to show you something that I don't recommend using at this point. I mean, at the point of beginning learning, and I will explain why. But still, I would like to explain it. So if you see this somewhere, that you understand what this means. And I'm talking about the var keyword. Instead of typing the data type like int, long, or string, we can simply type var and then the name of the variable. For example, let's say again, I don't know, name2, doesn't really matter. And what's important is that we need to give this variable immediately a value, like this. Doesn't really matter. And the reason is that we need the compiler to be able to infer the type of the variable based on the value assigned. So we must initialize the value. What's important is that even though we are using var and we are not writing the data type explicitly, the data type is still fixed, which means that we can't assign a different type of value to the same variable later. So for example, we can't do something like this because name2 is considered a string. Now, I really don't recommend using this at this point. I really suggest that you use explicit data types, that you understand what types you are using. Actually, the only place that I've seen this, that I know that the usage of var is mandatory is when using anonymous types. Until you get there, you can easily use explicit data types without var. Okay, now that we've seen several examples, I just wanted to say a few words about variable naming. First, as you probably already understood, we can't repeat variable names. And the reason is that we access the variable by its name. So if we define two variables with the same name, how the computer would know which variable to access. So yeah, different variables should have different names. A variable should begin with a letter or with an underscore. This is also valid. A variable name cannot contain spaces or special characters. And if you need to use multiple words in the name, simply use camel case. Camel case is a type of casing where the first word is written with a non-capital letter, while all other words start with a capital letter. Now, another important point is that C# is case sensitive, which means that if we have, for example, a variable named age, and then a variable named age like this, age and age are two different variables. And the last point is probably just a recommendation. It's not a rule of the language, of the C# language, but variable names, it's better to have meaningful names for variables. And the reason is that if you create variables like this, for example, maybe right now you understand what this means and what var1 is intended for, but probably even you will not remember what you meant when you look at this later. So variables should be named according to what they are meant to. Now that we understand the basics of variables, we can continue to more complex topics. Thank you, and see you in the next lesson.